Physical science. All right, guys, we're coming up to another test. You've been working hard, doing everything that you possibly can. I'm going to say, at least I hope so. I know that it's difficult to learn everything through a computer screen. I get that, but just keep trying as hard as you can. Work hard, all right? Don't give up. Don't just wave the white flag. You guys can do this. I know the effort can be there, all right? So the purpose of this video, we're doing what we would normally do, a little test prep review, okay? Your guys' test is Friday, all right? I'm going to upload this video today. Make sure that you get it, you watch it again and again and again. Pause it, write down all this info. You get that 1 page of notes. Use it wisely, all right? Make sure that if you have questions, you ask those questions prior to Friday. We're going to do a Zoom this week. Make sure if you have questions, show up, be there, ask the questions. That Zoom is just for you guys, all right? And let's jump into it. All right, so Chapter 11, some questions your way. The first question for you, a unit of pressure is called a what? A unit of pressure is called a what? What's the answer here? It's a Pascal. All right. Next question. Water pressure increases as what? Water pressure increases as, and then there's a blank there. What? It would be as depth increases. So as you go further down in the ocean, what happens? Water pressure goes up. Okay, next question. Which type of substance does Pascal's principle deal with? Which type of substance does Pascal's principle deal with? When I say substance, I mean, is it a solid, a liquid, a gas, a fluid? Remember that word? It's a fluid. All right, so a fluid includes liquids and gases. Fluid goes and it describes both parts. All right. Let's move on. Another question here. Okay. What effect does a buoyant force have on a submerged object? What effect does a buoyant force, remember, buoyant force acting in this direction, have on a submerged, in other words, slightly underneath the water, object? What effect does the buoyant force have? It causes a net force acting upward. That's the answer there. It causes a net force acting upward, meaning against gravity. Gravity going down, buoyant force acting opposite, going up. All right, next one. A ship stays afloat as long as the buoyant force is what? So remember, a ship in the water, partially underneath the water, mostly above it. A ship stays afloat as long as the buoyant force is equal to the ship's weight. All right? Ships can weigh tons and tons, and yet they're still able to float as long as that buoyant force pushing against it is equal to the overall weight. Remember, there's going to be a dispersion of weight. All right? That's why ships are not just these skinny, pointing into the water type objects where they would just pierce through it. They have to have a wide base. All right. Next question here. I'm going to give you 4 different objects. Wood, copper, mercury, rubber. All right, again, that is wood, copper, mercury, and rubber. Which of these is the least dense? The least dense? Think about it. Which one do you think? It's wood. Wood is the least dense of those. All right, next question. A substance whose shape can easily change. Again, think of a substance. Might be a solid, a liquid, a gas, or a fluid. Remember that in this. Which substance can easily change its shape? It's a fluid. Remember, fluid, again, it's liquid, could be gas. Those can take any shape. Whatever room they're in, whatever object they're in, they take the shape of that object. All right, next question. I know you guys love true or false, so let's do a true or false one here. All right, in a stationary fluid, what does that mean? Not moving fluid, all right? Stationary body of water. The buoyant force, that's the key phrase here, the buoyant force is exerted equally in all directions. Is that true or is that false? Is the buoyant force always dispersed equally in all directions? No, it's false. It's only up, opposite gravity. All right, next one. Let's do another true or false one at you here. As an airplane wing moves through the air, remember the shape of it, slightly curved on top, pretty flat on the bottom. What does that cause? Think about why the shape of that wing is that way. As an airplane wing moves through the air, air moves faster above the wing than below it. Is that true or is that false? That's true. All right, the shape of an airplane wing, even the shape of a bird's wing, the purpose of that is so that air moves faster over the wing, slower underneath it, causing what? Lift. All right, it decreases the pressure above the wing, increases the upward force below the wing, which is by definition lift. All right, let's do two more. Okay, pressure blanks as the area over which a force is distributed increases. So in other words, what does pressure do as the area over which the force is distributed is increasing? Pressure decreases as the area over which the force increases. There's a lot of fancy words just to say this is a great statement that explains why a snowshoe works and wearing something like high heels in the snow doesn't work. Snowshoe distributes area over a larger surface or a larger amount of space. Therefore, it decreases the pressure being exerted on the snow. If you're wearing high heels in the snow, you have a small amount of area and all that pressure is right on that one area. You're going to go straight into it. All right, last question here. According to Bernoulli's principle, remember what Bernoulli's principle helps us explain. According to Bernoulli's principle, the pressure in a moving stream of fluid is what than the pressure of the surrounding fluid? Remember, fluid could be gas. This could be describing an airplane wing. According to Bernoulli's principle, the pressure in the moving stream of fluid is lower than the pressure of the surrounding fluid. Why do we know that? Because airplanes stay in the air. If airplanes actually drew more pressure towards them, they couldn't fly. They would be pushed down. But there's a lot more pressure around them than there is directly on them. That's why lift works. All right, guys, that covers it. That's enough review there. Get that one page of notes. Utilize it wisely. Again, if you have questions, show up during the Zoom meeting. And if you can't be there, then email me questions or personal message me these questions. And watch this video again and again to make sure you get this info down. All right, miss you guys. Hope you're doing well. And I'll see you in the next one.